Good day, everyone. We continue with Chapter 8 and we are still under the subtopic 8.4, the normal distribution. Today we will look at destandardizing. Previously, we have learned how to find probability from standard normal table when we are given Z value and when Z is a standard normal distribution. Destandardizing is when we are given the value of the probability and by referring to the standard normal table, we find the corresponding value of Z. So now let us look at destandardizing. Before this, we have learned how to find the probability when we are given value of Z. Today, when we are given the value of probability, we will find the value of Z. We have learned that the total probability of the whole bell curve is equals to 1. And the symmetry line is here at Z equals to 0. So when Z is greater than 0, probability is equals to half of the total probability of the whole bell curve, which is 0.5. So when we are given equation probability of Z greater than A is equals to 0.5, which is half of the total probability, then we know that A is equals to 0. The value of Z, which is A, is equals to 0. So when we were asked to find value of A, given that probability of Z greater than A is equals to 0.695, observe that this probability is greater than 0.5. So we know that the area is more than this area, more than half of the total probability. So probably the line of A is somewhere here. So this is probably where the A is. And in fact, when we try to find this probability from the standard normal table, it is not available there because the area is bigger than what required in the standard normal table. The probabilities given in the standard normal table only less than 0.5. So if it is more than 0.5, then the table is, or the value of probability is not available in the standard normal table. So what we do to find A is, instead of referring to this bigger area here, we find A by using this smaller area. So what we need to do is, the probability of the smaller area is 1 minus the probability of this bigger area, which is in this case 0.305. So our equation now is probability of Z lesser than negative A, which is this area. Negative A, because A is at the negative side, so it should be negative and towards the left. So A should be negative, yeah? So when we find the value of Z from the standard normal table and the probability is 0.305, we found that the value of Z is 0.51. But because A is negative, so therefore A is equals to negative 0.51. A similar concept when we were asked to find value of A, given that probability of Z lesser than A is equals to 0.695. So again, the probability given is bigger than 0.5. So if it is lesser, it is actually referring to the area on the left. but because the probability is greater than half or greater than 0.5, the line A will be at the right area. So it looks like this. So to find A, instead of referring to this bigger area here, now we refer to the smaller area. And observe that this probability is the probability for the bigger area here. So therefore, to find A by referring to the smaller area here, we have to take the probability of the whole bell curve, which is 1, minus the probability of this bigger area here. So the probability for this smaller area here is 0.305. So now we can find the value of A. In this case, A is positive because A is at the positive side. So now the equation is asking us to find value of A when probability of Z greater than A is 0.305. So therefore, A is equals to 0.51. So now let us look at example 15. If Z is a normal distribution with a mean 0 and variance 1, find the value of A if given that probability of Z greater than A is equals to 0.1093. So observe that the probability is less than 0.5, so the area is still at the right tail. So let us find the probability for 0.1093. So there it is. So to find the Z for that, it is 1.23. So therefore, since A is at the positive side, so A, the value of A is positive, 1.23. Question B. Find A given that probability Z lesser than A is equals to 0.0021. Observe that the probability is less than 0.5. And this lesser than sign here referring to area at the left tail. So if the probability is less than 0.5, then the line of A is at the negative side. So let us find the value of Z. The probability 0.0021 is here. Therefore, Z is 2.87. But because it is at the left area, so A is negative. So therefore, A is negative 2.87. Question C. Find value of A given that probability Z greater than A is equals to 0.7517. This time, observe that the probability is greater than 0.5. And the sign here is referring to the right tail area. So if it is more than 0.5, means the area actually has crossed over to the left area. So instead of using the bigger area like what we have learned before, we find A by referring to the smaller area on the left. So therefore, the probability of the smaller area on the left is 1 minus 0.7517, which is 0.2483. And now it is the question is read as probability of Z lesser than A. And A here, remember, must be negative. So that's our probability of 0.2483. Value of Z is 0.68. But remember, this is at the left tail, so it is therefore negative. Question D. Find the value of A given that probability of Z lesser than A is equals to 0.8336. Observe that the probability is greater than 0.5. And the less than sign here referring to area on the left. But when the probability is greater than 0.5, so the area has crossed over to the right tail area. So therefore, instead of finding A referring to the bigger area, we now refer to the smaller area on the right. So the probability of the whole bell curve minus the probability of the bigger area. So what we have is the probability of the smaller area on the right. So now the question is read as find the value of A with probability Z greater than A is equals to 0.1664. So probability 0.1660 is here, and the value of Z or A is 0.97. And since it is at the right area, so A is positive. Question E. Find value of A given that probability of Z greater than A is equals to 0.5948. Observe that the probability is slightly bigger than 0.5, but it is bigger than 0.5 nonetheless. So the area, as you can see here, when the greater than sign is given, means it is referring to the area on the right. But because it is greater than 0.5, therefore the area has crossed over to the left tail area. So it's just like what we did before. Instead of finding A referring to the bigger area, now we find area by referring to the smaller area on the left. So the probability of the smaller area on the left, we found it by taking the whole probability of the bell curve minus the probability of the bigger area. And now our question is read as find value of A given that probability of Z lesser than A is 0.4052. And we know that A here is on the left. So therefore A must be negative. So probability 0.4052 is here. Therefore Z is, or A is 0.24, but because it is on the left, therefore A is negative. So A is equals to negative 0.24. F, last question of example 15. Find A given that probability Z lesser than A is equals to 0.9292. Again, observe that the probability is greater than 0.5, and this less than sign is referring to the area on the left. So when the probability is greater than 0.5, the area has crossed over to the right. So now to find the value of A, instead of referring to the bigger area, now we refer to the smaller area on the right. And we know that the probability of the smaller area on the right is 0.0708, which is taken from minusing 0.9292 from the probability of the total bell curve. So therefore, the question now read as find value of A given probability of Z greater than A is 0.0708. So the probability is somewhere here, yeah, this one. And the value of Z is, or the value of A is 1.47, and it is positive because it is on the right tail area. So therefore, A is equals to 1.47. That's it for now. Thank you. Stay safe and have a nice day, everyone.